So we're going to build a linear programming model for which we first need to define the sets, which are two, F for funds and T for types. And using these sets, we're going to build parameters and variables. The parameters are those elements of information that are not those we have the possibility to change. They do not reflect our decision, but they are relevant. And in this case, those are B, which is the total budget that we cannot exceed, the returns and risk per each fund. So we have this index F because we have two values, one for risk and another for return per every fund. And then we have the maximum and minimum values of the money we want to invest per type of fund. So in this case, we have two values per type, not per fund. And then we have the minimum number of funds we want to invest in. And finally, we have a binary parameter, which is 1 if fund F is of type T and 0 otherwise, which is this omega here, which allows us to build constraints and to impose that these min and max requirements are met. And finally, we have the variables, which are two. One is the money we invest in every fund, which is a continuous variable. And alpha is a binary, which is 1 if we invest in fund F, no matter how much we invest, but we invest 1. That means alpha should be 1 and 0 otherwise. This is needed for us to compute this number of funds we are investing in and comparing it with this n, which is the minimum we want to invest in. So these are the constraints. First, we need to impose that the total amount we're investing, which is the summation of all xf, is not larger than b. That's the first constraint. Then we have two constraints where we are summing all the investment of the funds corresponding to a type. Notice that this constraint is defined over all t, for all t. This is for all t. So that once we choose a type of fund, this sum here only considers those funds that are of that type. And we sum all the investment and cannot exceed the maximum and should exceed the minimum we impose. Next, we have to invest in at least n funds. So if we sum all these alpha, no matter what type of fund they are, that should be at least n. But if we don't do anything else, these alpha and these x values are not linked, and we could have solutions that do not make sense. That's why we need these two constraints. The first one says that if xf is 1 or is larger than 0, for this to occur, this is the budget. It's like what we call in linear programming a big M, but it's the budget. If this is larger than 0, for this to be satisfied, alpha f should be 1. Because if it's 0, that is 0, and that is not larger or equal to any value that is larger than 0. In addition to that, we put this other constraint, which says that if this is 0, okay, this is less or equal than this we have to our right. So in that case, this is 0. So in this case, for sure, if xf is 0, alpha is 0. And if xf is larger than 0, x alpha is 1. So we are linking x and alphas, and then this will operate and will apply correctly. And finally, we have the objective functions. Okay, this one, the maximization function, computes the revenue or the return, which is 1 plus the return times the investment we're making in that fund, which we want to maximize. And this one here minimizes the risk. KF is the parameter related to risk, and somehow that summarizes whatever we consider risk when investing in these funds. And we wish to have this as high as possible and this as low as possible, but we can see in the data we'll have that typically when we have larger return, we have as well larger risk. So there's a trade-off there to be found, and that is how we're going to use optimization and a multi-objective approach to deal explicitly with that fact.